are whiteboarding, building training an LLM from scratch. You know what I mean? Um, with with like, how do I say, with my high level understanding of like the transformer, the architecture, and just like, training, how do I say, gradient descent, blah 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 in general. What would I do? You know what I mean? If I had to build it from scratch, um, what would I do? And I think it's a good fun exercise. It's easier than reading because it's more involved for me. I'm pretty sure it'll be better cognitively for like my actual retention, and it's easier to make so many pros. Um, so I'm gonna try, I'm gonna fail, I'm gonna iterate, and then eventually we're gonna get it. So let's just jump right into it. Let's start with erase that, and then full screen exit. Perfect. Okay, and big test is that this needs to be synced. Okay, we're back. We're back. We're so back. Okay. This is attempt 5. You guys have no clue. You have no idea how many times I did that little test and it was in fact out of sync. Absolutely horrendous. Okay. So, oh my goodness, I'm so happy now. Okay, let's see. Let's see. Train today. We're going to train an LLM. Okay. So for me, I'm thinking about training in an LLM. First thing is text. You know what I mean? Um, let's see. Is so we have data. I think I already need to get smaller. Is there's what's our data? Ooh, was that glitching? It's better if I don't see it. It's so much better if I don't see it. I'm not watching this. I'm not aware of how far behind that's working. So we have data, and that is the, let's say, just text of the internet. Okay. Data text to the internet. How are we going to turn it into an actual useful data set? Let's see. First thing is going to do, we have to tokenize it. You know what I mean? Okay. How are we going to tokenize it? Let's think about that. Time complexity, off the top of my head, I'm thinking about like BPE. Are you going to BPE the entire internet? Like, what's it called? What's the time complexity for tokenizing? I don't know. We'll come back to it. The first thing is, how do I say, is now I have tokens. Tokens have IDs. I have tokens. I have tokens. Tokens have IDs. This is my vocab. This video is horrendous. I'm going to have to fix it after the fact. I'm so sorry, but for my own sake, I need to continue recording this video. Um, and it feels like sort of like unauthentic in a way of like, well, why am I even going to post anything that's like completely useless for anyone to watch? But I need to go. I need, you know what I mean? I'm here, and posting to the YouTube channel is not more important than me actually performing this exercise. So I need to do this. Okay. Our goal is to train an LLM. We have data. We're gonna tokenize it. What's next? And like, how are we going to do that? I don't know. We have a, let's say, world.txt, and then we're going to BPE, and then what did that give us? You know what I mean? That gave us the vocab, and now we have, how do I say, the world now looks like this. I don't know. I would do it like this. Is I have I have vectors. of the entire world. I have a I have the biggest sequence of all time. Yeah, I have the longest sequence. Um, let's see. I have a sequence length vector. Yeah, because the whole world is like a sentence, you know? For example, what's something that I'm missing? What I like that I'm already thinking of missing is like, okay, those like rare case tokens is like, I don't know, how do I say? What about the beginning of thought token? What about the end of thought? Or end of, let's just say end. You know what I mean? Or like, yeah, let's just do like, you know what I mean? It's like those tokens that like, I don't know, that signal to stop writing. You know what I mean? But maybe that's sort of like a post training. But no, it must exist in pre training, right? So, those are tokens that we have to consider in our space that may be like a deterministic thing that we add to, you know what I mean? Is like we may do that in this era before we have, I'd like for that to be a different color, is before we have everything, is we're going to do it sort of like that, you know? Also, are we synced back up? That's very curious. That's very, very curious. We're not synced back up. Holy cow. Okay, I take it back. Um, so we're training an LLM. We tokenize. We do BPE. Um, then what? I still have a data set. Yeah. Oh, that's starting to make sense. I need a data loader. Yeah. I need a data loader. Let's see. Is like, sure, the world exists, but the world is not structured for training, you know? So, okay, I have a data loader, but what is a data loader going to do for me? It's going to like, um, am I going to say, oh, I like the thought of this. It's like, okay, if I want to do, uh, not SGD, let's do batch size of one. Let's do batch size of one. Is I just want a sequence length. I want a given sequence length of text. Is, I don't know, give me a given, give me a, I don't know, sequence length of text. So for example, the world looks like 1, 2, 3, 4, 5, 6, 7, 8. That's really bad to write it like this because it's not indexed out like that. But let's say that this is what the world looks like, and I say like, I don't know, give me a sequence length of 3 is like pull this out, you know? Is like pull, like this is going to be our training data point. Interesting. And we're going to see, how do I say? We're going to train the model on this sequence length. So I'm sort of imagining is like, oh, we did that whole thing with like the curriculum for Coconut where the number of latent latent reasoning tokens or whatever are used. Um, I would sort of imagine that I would also have a training curriculum for pre-training of context length. You know what I mean? As well, I would start with sequence, just you know what I mean? Is like just like the generic thing of like I don't know fully. This would sort of be like an experiment I would do. Is like I wouldn't do, or maybe not. I don't know. Is so you could do a a word and say um predict the next token. You know what I mean? And you can do that for, how do I say? There's also this notion of like how many data points you have. It's sort of, is it a linear decrease? I'm not sure. It's definitely strictly decreasing. But is it decreasing in a, how to say, is it decreasing like this, or is it decreasing like this, or is it decreasing like this? I'm not sure. Because you have um what's it called? This is a whatever exercise. This is a normal, they're very classical exercise. Someone could totally do this. I'm not doing this off the top of my head right now. It's like, how do I say it? Is it log? It's not log, which means it's the backwards of log. So I think it decreases like this. Um, is when you have a small number of, how do I say, for training a sequence length of one, let's say, is sequence, and like let's say the world. Let's say no. Let's do sequence. Yeah. Let's do it is number of data points. So you have the sequence length that you're trying to train on, and then you have the number of data points that you can train on. Um, that's decreasing. This is too much of a tangent. Um, what's it called? So we have that is our data loader is going to select a sequence length of text. What else would it do? It could do it, you know, it would also load it for SGD. Like it needs to know what it's pulled from. Is like, how do I say? The world. How do I say? I need an object, data object of the world. I need a data object that is the world in text. And then our data loader is going to um, sample from it. And I want to know which ones I've sampled. You know what I mean? So that I don't know. So my samples are unique. Is I'm not going to do this and then this. I am in fact going to do actually segmented, because my loss function is going to be across all the entire sequence length. And that's another thing to be sort of curious about is the sequence length, this sequence length that we're going to do next token on is still a single data point, even though we're performing loss on more tokens per batch. So if your batch size is one, how do I say it? No, if your sequence length is one, then the tokens that you perform inference on in a batch size of one is one. But if your sequence length is 20, then the tokens that you perform inference on is 20. You know what I mean? You're going to get next token for every single one of them. Um, so that is an interesting thing. And I'm curious, does does training loss for like a super large sequence length also support performing loss for a shorter sequence length? I'm not sure. And that's where I'd sort of like trade off of like sort of like, is it like a recipe thing of, you know, if bigger means denser, but you also can't just do like a whole bunch of text and then do next token and like all of the loss on it, because then you only have one data point. Ooh, I'm not sure. Like I don't know. Like what if you just toss in the whole internet? You know what I mean? You just did the biggest sequence length that your GPUs can fit, and you perform loss on that. But then you have a batch size of one. Oh, well that's it. You have a batch size of one, which means you have a singular data point. So SGD isn't a fan, because you're going to do that. You're going to get loss. You're going to, how do I say? Yeah, you're going to overfit like crazy. You're going to concatenate, or you're going to aggregate the loss, and you're going to do backprop, and then what? You're going to put in the same data point. Um, and then all you're going to be able to do is regurgitate the internet. Exactly. Like you would actually just like memorize the internet. You wouldn't even, but maybe the internet's like so big. It would, I would imagine it would just collapse. Is like, I don't know, if you gave it like a sequence that it's never seen, it would suddenly like lose its mind. You know what I mean? You would perform significantly worse. Is like you still have to sort of like control generalizing in the sense that when you do a smaller sequence length, you can do there's so many sets of words that you can fit in the particular sequence length that like we have on the internet. You know what I mean? Is like a sequence length of like 20. There's plenty of unique sequence lengths of 20 such that you in order to perform well on all of those data points, you would have to sort of generalize, you know? But if you just have one data point of sequence length internet, cardinality of internet, um, that would be an overfitting case. So that's interesting. But I don't know, maybe we're not even close to that. You know what I mean? Maybe that problem isn't the bottleneck and attention is still the bottleneck before that type of issue, you know? Um, or maybe, I'm sure there's other solutions and whatnot. So let's see, I have that. What do I have now? I now have from the data loader, I have this vector and it says 28, 91, um, 53. Okay. And this vector is our selected data point to train on. This is our data point to train on. And if we did, how do I say, our data loader, if we had queued it to give us multiple data points, like this is sort of just like our tensor, is like now we have um, a batch size by sequence length matrix. And then if we expanded it, we would just have a batch size sequence length D model tensor. We're already in tensor space. Um, Ooh, ow. Confusing. I say I want to do this in code. Okay. Wow. I'm imagining the most evil for loops is they're just nested for loops. They're just nested lists. You know what I mean? Is so like D model is a list. So per token in sequence, per sequence in batch. And that would be it. And then you would do the operations in that sort of space is like, I don't know, say you did like per token in sequence to reduce X matrix, and then per X in batch, you did an operation. I can imagine horrendously inefficient. Okay, so I can give myself a NumPy tensor. I could give myself a NumPy tensor. And then what? Could I perform rope on that tensor, on that NumPy vector? Yeah, I could. I could perform rope on it. And then what? Attention? Whoa. Whoa, 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 whoa. So this is sort of, okay. Ah, I could do a forward pass. I could do a forward pass by hand with randomly initialized weights, but a backward pass, I need PyTorch for AutoGrad because I don't know how else I'm going to do that. But yeah, so like then what? I think I'm already lost. It's okay. I have data, I have a data loader. Then what? Like we have our data point. You would just put it into the model. You know what I mean? Is like we have data, we do BPE, we have data loader, for which is, and then we have data loader and we have model, and then we need a training loop. So like we need the actual training file, and that training file is going to like call the model object and the data loader functions, and then like queue SGD, give the data points into the model does forward, then we take the loss given the data loader information, because the data loader gave us the inputs and the outputs. So that's another thing. And then we have the model, it did forward. We get the loss, and then we do backward. And then we would just continue doing that. So data, BPE, model, data loader, training. What am I missing? It's time to reference code is, so there's these 5 functions that I think I would use. We have BPE, data, generate is actual inference, prepare data. I did sort of mention that in the sense that, like, I wonder what this one does. Let's see. Tiny Stories URLs. Download Tiny Stories, train a BPE tokenizer on it, and tokenize the train validation splits into flat NumPy token files for memory maps training. Tiny Stories is the canonical small corpus for this workflow. Usage for collab. Produces tokenizer JSON, train bin, valid bin, metadata. So these are tokens IDs. This gives us the no, train val is interesting. Train val. These have to be a whole data set. You download it. That's the whole thing. That's the main. Yeah. That's mostly what this does. Is okay. It actually just like gets the data. Special tokens. Yeah, that's what I was sort of talking about. EOS ID. Yeah, I think so sort of interestingly is maybe I do end up going backwards into doing, maybe I go back to the math of like, well, how would I code the autograd graph? Because doing the forward pass, I think, is actually is not that bad. Which could be a good exercise for us to like vibe code, is like, vibe code, and like my depth of understanding is like, okay, let's do the forward pass and generate text for random weights. We're going to get random text out. But like, in LLM, that makes no sense because it doesn't learn. And yeah, that's something I could do. I'm struck. For the sake of code, that's something that we could do tomorrow. You know what I mean? Is let's get some text and let's do it in NumPy. And let's see if I can do the forward pass of general attention transformer with random weights and actually generate text. Generate not even close to slop. Like there's nothing coherent. It'll just be like tokens. And can we output from our vocab space, and can I make the matrices and the tensors align in the way I expect them to? But like even doing rope and attention, all that stuff is not gonna matter um if we can't update the weights. So that's what I need. We need PyTorch for. Yeah, like torch no grad, or how are we gonna like step things? Cosine. Yeah, back prop. Not trivial. You have the update rule. Is our optimizer just going to be Atom? The whole thing is the class? No, it's not. Cosine. Is anyone using this function? It's defined. Clip grad norm. Clip it. So who's pulling from optimizer? Model, train. Train is calling model and optimizer. Good. This is our training configuration. We set the seed. This is to calculate the loss. This is to save a checkpoint. This is to load a checkpoint, whatever. Our main loop. Argparse. Oh boy. Build the model. Model. Put it to your GPU. Count the parameters, sure, whatever. Define your optimizer because we pulled it. Optimizer is the object that we defined. Training loop. We have our thingy-majiggy. I don't know why we're calling model.train. Time, blah, 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 blah. Until we've done the max steps or there's something to stop us early, maybe. I guess not. We just run until max steps. This is for step in range. For micro, very interesting. I don't know what that means. Okay. So today's video, I think, is fairly short. So, like, let me think about that. The forward pass is trivial. Backward pass requires these notions of like states and stuff. So I could build a very stupid language model. I could build a small one. It'd be stupid. I could do like the matrix calculus. There's no calculus. I can do the linear algebra. We can do softmax. We can linearize. We can normalize. Like we can make sure things don't explode. We can do RNN. Hell, could we even do? We could even do coconut forward pass training just without loss. And the reason we loss is so hard for us is because I need to use PyTorch in order to have weights on a GPU and do backward pass. But let's see. The smallest. There could be sort of a name for it. I don't know. What would I call like the smallest LLM that um that doesn't learn, that you can't train, an untrainable tiny LLM. I wonder if there's like a character in a show that's like equivalent to. It's like you know like we made like Ralph loops is like, well, what's the that's the tiny untrainable large language model. We could do that. How do I get to doing backprop? Say I built the forward pass. Okay. What's stopping me from being able to do the backward pass is that I'm claiming that I would do it in NumPy. If I did it in PyTorch, isn't PyTorch backward just model.backward? You know what I mean? So let's check in on that again. Is I would do model, forget transformer block, whatever, forget generate, forget forward. There's no way this is what you did for the forward pass. Holy cow. This is the whole forward pass. That's how trivial it is. You have batch size and tokens. Then you have positions. I don't know what we're doing with that. Oh, this is to actually get like M. Okay, this is like the indices of the positions. Okay, you embed them, and for each block, you're going to perform. Wow, you're going to do a transformation with X and their positions. Wow, and you're gonna loop it. Wow, and then X equals You just put it into the final head, and then wow. Okay, let's see. Generate. Where's back? Where's backward? Generate. We don't need the generate function. This is literally just to have fun. Um, Wait, I'm confused. Where's back? There's a transformer block, whatever. Causal multi-headed attention, whatever. Rope. Oh, wow. There really is only a few things in here. These are all helpers. Oh, wow. Wow, wow. This is actually not as complicated. I've read this file, and I came back to it, and I thought it was complicated. Turns out it's not. I'm very curious about what's going on outside. Okay, but then when do we do model.back? I don't have control.f in Voltchat, so I can't find it. Let's see. Model. Ooh. Let's see. When are we doing model.back? Well, we have to take a step at some point. We have logits, loss.backward. Whoa. Then what's loss? Loss. Oh, wow. Torch.neural functional cross entropy logits. Wow. You see how much, like, you see how that's just it? You know what I mean? Is like, they made like they abstracted away the hardest part. It's like, okay, so I don't understand backprop. I don't need to. I just do loss.backward. What? So loss equals torch.nn cross entropy because it's the logits. And it's the cross entropy logits of this with respect to y. And then you're just changing the size because you're taking a view of it. And then by design of like all the data structures in PyTorch is it's going to work. Wow. So this is what I'm seeing. I'm seeing that the forward pass is trivial, and I'm seeing that PyTorch abstracts the back pass. So I should try to do the forward pass in PyTorch and see what goes on. With a dummy model, with a dummy tiny model. Ooh, I think we can do that this week. Okay, because we can vibe code it too. Okay, I want a data set of text, I want to do BPE, and then I want a data loader, I want to do like SGD. I want to do it in PyTorch, and then I want to have Torch do the loss dot backward for me. And we're gonna make it like so tiny, and it's not gonna do anything, and we're gonna watch the loss. But that's gonna be like that is it. Like that's like the smallest version of the LLM. We'll have D model equals 4 or something. um, yeah, yeah. Um, because you can have a tiny D model, and then sequence length is arbitrary. We can do whatever sequence length we want. Allegedly, you just like multiply the matrices and you do rope. Ooh, okay. I like that. I like that. I like that. I think that's fun. Um, so yeah. Well, I think I might try that for tomorrow's video. Ooh, ooh, that is certainly an idea. That is certainly something to try. Um, I do worry about how I would do that presentation wise. I think I would just talk to Volchat. I would talk to Claude about it first, and then I'll come back and then we'll see tomorrow if I'm able to actually do that. But yeah, I think I'm fine with that. Um, yeah, iPad needs to get fixed. Anyway, have a good one. I'll see you tomorrow.